Today's lesson is on factoring. Let me ask the question first. What does it mean to factor? To factor means to express as a product. If I gave you a numerical example like 15, your immediate response would be 15 is 3 times 5, right? 3 times 5. In other words, when we say to factor a number, it means to express it as a product. To express it as a product, 3 times 5. Nobody thought to take 5 and add it to 10 in order to get 15. It gives you 15, but when I said factor, you think of a number times another number. So to factor just means to express as a product. Okay? Now, in case you are seeing this by video, we're going to make use of two references in the explanation. The first is going to be the book Basic Algebra, One Step at a Time, which can be bought in the SCC bookstore for about $10.85 or something like that. We'll be on page 115 of that book to do the explanation of factoring the common factor. Then we'll switch over to a handout that I've prepared, and this handout is called Trinomial Factoring, and it can be obtained through my office. If you're seeing this by video and you need a copy of the handout, just call my office at 328-2249 or 2345. That's easy to remember, 328-2345. And I'll be happy to get you a copy of the handout. All right? First thing I wanted to look at is to factor a simple example, like let's take another example, 18. How would you factor 18? Any ideas?
2 times 9.
2 times 9. Okay? Or somebody else might have said 18 is 3 times 6. Right? Now, which is right? They're both right. You mean there's more than one answer to a math problem?
No.
Oh, well now wait, let's go back to 3 times 9. Is there anything you can do with 9?
About 2 times 3 times 3.
Right? You could have made that 2 times 3 times 3, or you could have written it 2 times 3 squared. Is that right?
What about 2 to the 4th?
2 to the 4th?
Yes.
I think that's 16, isn't it? Listen, I'll get to that next. Hang on to that thought. Now, how does this compare to 3 times 6? 3 times 6. What would be 3 times 6? 3 times 6 would be 3 times 6 is what? 2 times 3? So you get 3, 2, 3, like the Sanford prefix, 3, 2, 3. How could you also write 3, 2, 3? 2 times 3 squared. What I wanted you to see about this is the answer comes out the same, doesn't it? In other words, there will be a unique answer if we're factoring these numbers down. If we factor them all the way as far as you can factor it, it'll come out to a unique answer. It'll be the same every time. And what special name do we have on these numbers that we have when we factor it all the way to a point that you can't factor anymore? What kind of numbers are those? 2s, 3s, they're prime numbers. Okay, prime numbers are numbers beginning with 2. Notice that 1 is not a prime. 2, 3, 5, 7, and so forth. The numbers that you cannot break down into a product of 2 smaller numbers. Those are called prime numbers. Right. Let's take a larger number, like 45. No, 16. We were going to do 16. The number 16. What can you do with 16?
2 times 8.
2 times 8. Anybody have a different idea to begin
4
with?
times 4.
Somebody might have said 4 times 4. Right? What could you do with 2 times 8? What is 8? Take that 8. 8 is actually
2 times
2 times 4. Now what's 4? 2 times 2? Okay, so what we have here is 2 times 2 times
4. 2
2 times 2, which would actually be 2 to the fourth power. 2 to the fourth power, okay? What about if you did 4 times 4? Would that give you the same result?
Yeah, because that breaks.
That would be 2 times 2, and this would be 2 times 2, and the total result would be 2 to the fourth power. So whichever way you do it, it comes out 2 to the fourth power. All right? All right, I'd like to look at a larger number, a really larger number, like on page 116. Turn to page 116, if you will. And on page 116, I'd like to look at number 28. Number 28, page 116. And the problem is 3060. I have a couple of things I want to do with this number. First of all, we've got a big number. Nothing leaps into your mind. You know, like I said 16, you said 4 times 4. And probably there is no immediate breakdown of a large number like that. So what we have to do is just find any number that divides into 3060. Now, it might help to talk about some divisibility rules. How do you know if a number is divisible by 3 or by 9? Have you ever seen these smart people, these people act like they're so smart, that get on TV and they'll take a number like 2, 3, 0, 4, 5, 8, 1, 0, 4. And they'll put a huge number like that on the board and say, you know, I think that number is divisible by 9. Is that number divisible by 9?
Yes.
What would be a good way to tell if a number is divisible by something? By any number? Use your calculator, right? In other words, just put that number in the calculator and divide by whatever number it is and see if it comes out even. Now, the guy that gets up on TV and acts like he's so smart because he's doing all this in his head, he's probably got a trick somewhere. You know, there are a lot of tricks around. And when you're talking about divisibility by 9, there's a trick. What is the divisibility by 9 trick? Add the digits. If you add the digits, if the sum of the digits is divisible by 9, then the number's divisible by 9. So that number right there would be divisible by 9, isn't it? What's the sum of the digits? 5, 9, 18, 27. Right? And the number 27 is divisible by 9. Now that rule applies only for 9s and 3s, doesn't it? It's only good for 9s and 3s. Now let's go back up to my original problem here. 3060 is divisible by what number? 9. Now it also ends in a 0, so what do you know it's divisible by if it ends in a 0? 10. And what that means is it's also, if it's divisible by 9 and it's also divisible by 10, it's also divisible by 9 times 10, which would be 90. Okay? And it's also divisible by a lot of other numbers, but what I need to do is find two numbers that I can multiply together and get 360. Can you think of a number? Just any number. 60. 10. There are dozens of numbers you could use. What if you just saw 10 goes into it? Does everybody see that 10 goes into that? Then what would you have? 10 times what? 306. All right? How do you know that it's 306? When you divide by 10, you just move the decimal over. What if it was a number besides 10? What would you do to find out what the other number was? What if I heard somebody say 60? So let's try it another way also and see if it comes out the same. 3060, and let's try breaking it down into 60. Now, how do you find out? Well, if you go 60, how do you find out what the other number is? Divide. Use your calculator. Take that calculator that you have in your hand, right, in addition to the one in your head, and take 60 and divide 360 by 60, and what would you get? 51. With the calculator, it comes out 51, okay? Now, I'm doing the problem in two different ways. Let's go back to the first way, and then we'll come back and finish this way in just a minute, all right? What would be What would be the 10? Can you break down the 10? 2 times 5. Can you break down the 2? No. Then let's circle that 2. How about the 5? You can't break that down. So these are prime numbers. You can't do anything with the 2 and the 5. But what about the 306? What number? 306, 9. All right, 9 goes into 306. How do you know how many times it goes? By dividing with a calculator. Take 306 and divide by 9, right? What would that be? 34. All right, my calculator people out there are giving me fast answers. Now, why did I circle that 9 and that 34? Because I wasn't paying attention, right? I was thinking about what am I going to do next? And that's what you're not supposed to do. You have to concentrate on what you're doing. That's 9 times, what'd you say?
34.
34, all right. Now, what about 9?
3 times 3.
3 times 3. Okay? And those 3's are prime numbers, aren't they? 3 times 3. What about 34? What's 34? What number goes into 34? 2. 2. So we put down 2, and then how do you find out what the other number is? Take 34 and divide it by 2. Is everyone clear on that? So that would give you your 17. So the final answer here is total final answer. We've got a bunch of 2's here. What's the answer with 2's? 2 to the second, okay? How about the 3's? 3 to the second, okay? And how about the 5? We got a 5, and we've got a 17, okay? So this is the final answer, and the way we usually try to write this, we try to put them in numerical order, from smallest to largest. We call that ascending order, increasing order, and then use the powers to make it simple as possible. Now, that will be a unique answer. That's the only answer you can get. You won't have to worry about whether your answer is the same as somebody else's answer. Okay? Any question on that? Okay?
Let's do the other one.
Do the other one? Okay, let's try that one. What about 60? What would 60 give you?
6 times 10.
6 times 10? All right. How about 51? No, let's do the 6 next. I'm sorry.
2 times 3.
The 6 would be 2 times 3. And those are prime, aren't they? Okay? By the way, this is, let's keep it separate here. How about the 10? 2 times 5, okay? And how about the 51?
17.
Right? If you can't think of, let's say you're sitting on this 51, you say, gosh, I can't think of anything that goes into 51. Then just start at the beginning. Start with what? 2. Does 2 go into 51? Doesn't go. So we try 3. And with calculators at hand, this only takes a second, doesn't it? Just take 51, divide it by 3. Do you need a calculator to know that this is divisible by 3? Remember the shortcut rule? Add the digits. What's the sum of the digits? 6. And that's divisible by 3. So it has to be divisible by 3. That would be 3 times what? 17? Okay? And those are both prime numbers. Now the final answer, drum roll time. Here's the final answer. 2 to the what? Second. Okay, that takes care of these 2's. 3 to the second. And then 5. And then 17. See? It comes out exactly the same. All right? Any questions on how to factor numbers? By the way, did any of you have trouble with your 9 times tables when you were in school having to learn the 9sies? You know, I want to illustrate that the rule about divisibility by 9 in this way. The fast way to get the multiples of 9. Here are the multiples of 9. We'll start with 1. We'll start with 9 and go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay? And then after we get to 0, we'll start over with 9 and go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And there you have all the multiples of 9. Okay? And notice about the multiples of 9, what's the sum of the digits every time? 9, 9, 9, 9, 9, 9, 9, 9, 9. Okay? Sum of the digits is always 9. Okay? Any questions on that? All right? All right, now.